Very good morning, dear students. So today, before we start the actual class, let us first take a pledge during this pandemic era of the corona COVID-19. So first we take the pledge to prevent the COVID-19 and to obey the some preventive measures. So students, today we will take this pledge. I commit to be vigilant and bear in mind at all times the risk of myself and my colleagues and students from COVID-19. I promise to take all necessary precautions that prevent the spread of this deadly virus. I promise to follow and encourage others to follow the key COVID appropriate behaviors. To always wear a mask, face cover, especially when in public. To maintain a minimum distance of 6 feet from others, to wash my hands frequently and thoroughly with soap and water. Together we will win this fight against COVID-19. Students, today we continue with exercise 15.1 and start with question number 50. The statement of question is triangle ABC is an isosceles triangle with AB is equal to AC. Prove that bisector of angle A divide triangle ABC into two congruent triangles. So here we are given with a triangle ABC. Triangle ABC is an isosceles triangle in which AB is equal to AC and AD is bisector of angle A. It means angle BAD and angle CAD both are equal, and we need to prove that triangle ADB and triangle ADC, these two triangles are congruent triangles. So for this we consider triangle ABD and triangle ACD. As per given condition, AB is equal to AC, and again as per the given condition, angle BAD and angle CAD, they are same. It is also given because AD is bisector of angle A, and AD is the common side of both the triangles. AD is side of triangle ABD and triangle ADC also. So therefore it is common side of both the triangles. So we can see side, angle, side. Side, angle, side of triangle ADB are respectively equal to side, angle, side of triangle ACD. So it means by SAS congruence triangles are congruent. So this proves the result. Similarly, question number 16 is extension of this question only. Here we need to prove that all the conditions are equal, same. Given is same, but here instead of to prove triangle ADB is congruent to triangle ADC, we need to prove that D is the midpoint of BC. So this is just further extension of this. When triangle ADB and triangle ADC are congruent, it means BD is equal to DC. It is by CPCT. CPCT means corresponding parts of congruent triangle. And once BD is equal to DC in this triangle, BD is equal to DC, then we can say that D is the midpoint of triangle, midpoint of side BC, not triangle. D is the midpoint of side BC, and this proves the result. Now we consider question number 17th. In the statement he said, in the given figure, AB is parallel to DC. This AB is parallel to DC, and AB and DC are equal also. We have to prove that triangle ABD and triangle CDB are congruent, and then AD is parallel to BC. So this is the given. In given we can write AB is parallel to DC and AB is equal to DC. And to prove two things we need to prove. First is triangle ABD is congruent to triangle CDB, and second is AD is parallel to BC. So here we consider two triangles, triangle ABD and triangle CDB. First of all, AB is equal to CD, it is given. Also they are parallel, so it means angle ABD is this angle, is equal to angle CDB. Why these are equal? Because these are alternate interior angles. As AB is parallel to DC and DB is transversal, so therefore these two angles are equal. and also BD is equal to DB, same side, and it is common to both the triangles, triangle ABD as well as triangle CDB. So we can say that triangle ABD is congruent to triangle CDB by SAS congruence. Now further, if two triangles are congruent, then their corresponding parts are equal. Now we can say that these two angles, angle ADB and angle CBD, these angles are also equal. Why? Because these are corresponding parts of congruent triangle. When we superpose these two triangles, B will goes to D and D will goes to B in this way, and then these are the corresponding parts. But at the same time, these are alternate angles also by the transversal BD on AD and BC and are equal. So it means AD is parallel to BC. So this proves the result. Now we consider question number 18th. The statement of question number 18th is, in the given figure, AC and BD are parallel. AC is parallel to BD and AC and BD are equal also. We need to prove that OA and OB are equal, CO and DO are also equal. So in given we can write that in figure AC is parallel to BD and AC is equal to BD. And to prove AO is equal to OB and CO is equal to OD. So again we select two triangles to which we can prove that they are congruent. So these two triangles considered to be triangle ACO and triangle BDO. First of all, angle ACO, this angle ACO is equal to angle DBO, is equal to angle BDO, is equal to angle BDO, this angle. So these two angles are equal. These two angles are equal as these are alternate interior angles, and AC is equal to BD. It is given in the question, and then angle OAC, this angle OAC is equal to angle OBD also. These are also by the alternate angle concept because AC and BD are parallel. So now we can see that angle of triangle OCA are respectively equal to angle of triangle OBD. So it means by ASA congruence, the triangles are congruent. And once the triangles are congruent, then their corresponding parts are also equal. Now corresponding parts are OC and OD. They are equal. OA and OB, they are also equal. So by CPCT we can say that OA is equal to OB and CO is equal to OD, and this proves the result. Now we consider question number 20. Statement says that triangle ABC is an isosceles triangle with AB is equal to AC. D and E are 2 points such that AD is equal to AE. So in given we can write in triangle ABC, AB is equal to AC, as well as AD is equal to AE, where D and E are points on sides AB and AC. And to prove is BE is equal to CD. So, in question, the statement says that show that BE is equal to CD. So first of all, we will consider those triangles which contain BE, CD, AB, AC, AD and AE. So those triangles are, one is triangle ABE and another is triangle ACD, and the selection of triangle is made such that we can prove that these are congruent also. So once the triangles are congruent, then by applying the concept of CPCT, that is corresponding parts of congruent triangles, we can prove that the triangles are congruent. So we select triangle ABE and triangle ACD. Here AB is equal to AC. In triangle ABE side AB and in triangle ACD side AC, they are equal. Also angle BAE and angle CAD, this angle is common in two triangles, and AE is equal to AD, this is also given. So by side angle side congruence, the triangles are congruent, And once the triangle are congruent, then by corresponding parts of congruent triangles, that is CP-CT, we can say that BE is equal to CT, and this proves the result. So thank you very much students for watching this EV, and hope the questions of exercise 15.1 are very clear to you, and practice these questions so that you can be able to take any condition which involve congruence and corresponding parts of congruent triangle. Thank you very much students.